Welcome, everyone, to a lesson in survival. Today, we're not just discussing compound probability, we're witnessing it. But before that, compound probability is the likelihood of two or more events occurring together. For independent events, multiply their probabilities. For dependent events, adjust for prior outcomes. Observe.
What is he doing? He's not attacking. He's charging? Oh my goodness! He sees the formulas! The equations needed to defeat Sukuna! Wait a second. He's reacting to them. Wait, no. He's manipulating them.
Precisely! He's manipulating the probabilities. He's not just reacting, he's
ガラスと
calculating.
商業勝利の狭間挙式村田
Oh no! no! He's still alive!
He did it! He actually did it!
He did it! And he did it by understanding, by using the principles of probability, just like we're going to do right now. Let's break down those problems and see how the math mirrors the magic.
Now that the battle is over, let's look over some of the problems that Gojo-sensei has encountered during his fight against Sukuna. Problem number 1.
To solve problem number 1, we need to identify our events clearly. We have 3 events. Event A, Gojo dodges the cleave slash. The probability of this happening is 0.5. Event B, the cleave slash successfully lands a hit. The probability of this happening is 0.7. And Event C, Gojo successfully counterattacks after dodging. The probability of this happening is 0.3. Now, let's analyze these events in terms of their relationships. First, events A and B are mutually exclusive. This means that if the man dodges the attack, he cannot simultaneously be hit by the cleave. Therefore, we can express their union as P of A union B is equal to P of A plus P of B. Next, we need to consider event C. This event can only occur if event A happens first, meaning Gojo must dodge before he can counterattack. To find the probability that he dodges and then counterattacks, we multiply the probabilities of these two events. P of A intersection C is equal to P of A multiplied to P of C. 0.5 multiplied to 0.3 is equal to 0.15. Now, we can combine these probabilities to find the total probability that at least one of these events occurs during a single attack. We express this as P of at least one event is equal to P of A plus P of B plus P of A intersection C. Since events A and B are mutually exclusive, we can add them directly. P of at least one event is equal to P of A plus P of B plus P of A intersection C is equal to 0.5 plus 0.7 plus 0.15. However, when we calculate this sum, we get 1.05. Since probabilities cannot exceed 1, we need to adjust our calculation by recognizing that if he gets hit, event B, he cannot dodge or counterattack. To find the probability of at least one event occurring without exceeding 1, we calculate the probability of neither dodging nor getting hit. P of not A and not B is equal to P of not A multiplied to P of not B. 1 minus 0.5 multiplied to 1 minus 0.7 is equal to 0.5 multiplied to 0.3, leading to 0.15. Finally, we subtract this from 1 to find the probability of at least one event occurring. P of at least one event is equal to 1 minus P of not A and not B is equal to 1 minus 0.15. So, the probability that Gojo either dodges, gets hit, or counterattacks during a single attack is 85%.
Problem number 2.
For problem number 2, first, we need to calculate the probability that Gojo successfully parries all 3 attacks. The probability of Gojo parrying a single attack is 30% or 0.30. Since each attack is independent, we multiply the probability of parrying one attack by itself 3 times. This gives us the probability of all 3 parries is 0.30 multiplied by 0.30 multiplied by 0.30, which is equal to 0.027. So, there is 2.7% chance that Gojo successfully parries all 3 attacks. Next, we calculate the probability that Sukuna lands at least 1 hit across her 3 attacks. To do this, we first find the probability that she does not land any hits in all 3 attempts. The probability of Sukuna failing to land a hit in a single attack is 1 minus 0.50, which is equal to 0.50. Since each attack is independent, the probability of failing all 3 attacks is 0.50 multiplied by 0.50 multiplied by 0.50, which is equal to 0.125. To find the probability that Sukuna lands at least 1 hit, we subtract this value from 1. 1 minus 0.125 is equal to 0.875. So, there is an 87.5% chance that Sukuna lands at least 1 hit across her 3 attacks. Now, we calculate the probability that both events occur, Gojo successfully parrying all 3 attacks and Sukuna landing at least 1 hit across those 3 attacks. Since these 2 events are independent, we multiply their probabilities together. The joint probability is 0.027 multiplied by 0.875, which equals approximately to 0.023625. So, there is about a 2.36% chance that Gojo successfully parries all 3 of Rayana's attacks and Sukuna still lands at least 1 hit during those attacks.
Now many of you would be wondering, how come Gojo Sensei still gets damaged even when he parried all 3 attacks from Sukuna? Well, to answer that question, the reason why is because Sukuna's slashes are super strong. They're invisible as well, and they move at the speed of sound, which is super fast. So, even if you manage to parry all 3 of Sukuna's slashes, it's practically impossible to parry them without getting hurt. Now for the last problem. Problem number 3.
To solve the main question, we define the following events. Event A, Gojo dodges exactly 2 out of 4 attacks. Event B, Gojo dodges exactly 3 out of 4 attacks. Event C, Gojo dodges all 4 attacks. We need to find the probability that at least 2 out of 4 attacks are dodged or all 4 attacks are dodged, which can be expressed as P of at least 2 or all 4 is equal to P of A or B or C. Since these events are mutually exclusive, we can add their probabilities, and that will be equal to P of A plus P of B plus P of C. Step 1. Calculate P of A. The number of ways to choose which 2 out of 4 attacks to dodge is shown. Calculate each factorial and substitute into the formula. The probability for each sequence is shown. Step 2. Calculate P of B. The number of ways to choose which 3 out of 4 attacks to dodge is shown. Calculate each factorial and substitute into the formula. The probability of each sequence is shown. Step number 3. Calculate P of C. The probability of dodging all 4 attacks is shown. Step number 4. Combine probabilities for events A, B, and C. The total probability that Gojo dodges at least 2 out of 4 attacks or all 4 attacks is P of at least 2 or all 4 is equal to P of A plus P of B plus P of C, which when you substitute will be equal to 0.2646 plus 0.0756 plus 0.0081. Simplifying will give you 0.3483. Thus, the probability that Gojo dodges at least 2 out of 4 attacks or all 4 attacks is 34.83%. The probability that Gojo dodges at least 2 out of 4 explosive attacks or all 4 attacks is 34.83%. If Gojo has already dodged exactly 1 attack in the first 2 explosions, what is the probability that he dodges exactly 1 of the remaining 2 explosions? First, determine the sequence of possibilities. If Gojo has already dodged exactly 1 attack in the first 2 explosions, we now focus on the last 2 explosions where he can dodge exactly 1 attack. The possible sequences would be dodge hit and hit dodge. This gives us 2 combinations. Calculate the probability for each sequence. The probability for each sequence, or the 1 dodge and 1 hit, is P of 1 dodge 1 hit, which will be equal to 0.3 raised to 1 multiplied to 0.7 raised to 1, which is equal to 0.3 multiplied to 0.7, which gives us 0.21. Combine probabilities for event E. Therefore, the total probability that Gojo dodges exactly 1 attack in the last 2 explosions is P of E following D is equal to number of combinations multiplied to P of 1 dodge 1 hit. That will be equal to 2 multiplied to 0.21, giving us 0.42. Thus, if Gojo has already dodged exactly 1 attack in the first 2 explosions, the probability that he dodges exactly 1 attack is the last 2 dismantle is 42%.
Once again, before we leave, we just want to say
Thank you for tuning in.